Hey kids, parents, and everyone playing at home. Right now we're going to talk about numbers. Okay, so like everything that's ever been known to anybody, we categorize our numbers because human beings want to categorize things. We still haven't learned our lesson. We keep labeling everything, and it's a little obnoxious, but numbers are going to stay numbers, I think. So in the beginning there were natural numbers. 1, 2, 3, a whole host of cookies I ate. But here's the thing. What do we do if I say, I'm not holding a pen? We'll get to that. Okay, so the natural numbers are what we call natural numbers. And they're what you count when you have something to count. 1, 2, 3, 4, 5, and on till the end of time. You see it? Natural numbers. Okay, whole numbers. Whole numbers are the thing that when you're a kid, you're like, which maybe you are, you think, why did they have a whole different number set just for 0? Which, whoa, don't get me started on 0. Okay, maybe. But whole numbers are the natural numbers plus 0. And I gotta tell you, sidebar, especially for the parents playing at home that are maybe curious and wanting to help their kid about number sets, there's a whole big thing about this. Do you know that people used to die for the existence of the number 0? How can you count something that's not there? But turns out you can. And in fact, science needs it. Okay, so those are the whole numbers. But then we had this whole subtraction thing. Like, what if you had 3 things, but you took away 5? How does that work? Now we're getting a little esoteric. We call those integers. And now instead of all these ellipses this way, 0, 1, 2, 3, 4, ... We also have to go backwards. -1, -2, -3. Okay? Those are integers. When you usually say something like whole numbers, what you mean are integers. It's just what you mean. So colloquially, you'll say, oh, is that a whole number? When really you meant an integer. Because integer includes all the negative. Like when you borrow money from your parents to go to the movies. Okay, so these are all fine and good and fine and great. But what if you split your cookie with a friend? Okay, I'm going to erase these for a second, but we're going to keep them in our noggin, okay? Or, look at this. This is called spatial awareness. Flippity flop. New board. See how easy that was? Okay. So, let's say you split your cookie. I have 1 cookie and I split it 2 ways. Or, I have 2 pizzas and I split them with 5 friends. Where do we put these numbers? Well, since these are ratios, we call them rational numbers. I think we should just call them rational. Rational just sounds weird. These are rational numbers. It is any number that can be written as a fraction. So then you say like, oh, so like 0.3 is 0.6 repeating. That's not a rational number because it's a decimal. No, but it can be written as 6/9, which becomes 2/3, which is a fraction. So some decimals are rational. Anything that can be written as a ratio or a fraction is a rational number. But then this poor guy back in 1000 BC, he was like, hey guys, I got this thing. We're gonna see if my glue works. Nope, still dry as a bone. So I figured something out, okay? If we have a square with both sides 1, then when I do, because of Pythagorean theorem, we're going to talk about that. When I do this way, I have 1 squared plus 1 squared is the square root is square root of 2. But I can't turn that into a fraction. In fact, it's impossible. And someday I'm going to show you this proof because it's totally awesome. And then another person died because they proved that, like, Pythagoras thinks all is number, the Pythagoreans. And then this couldn't be written as a ratio. This is where Latin comes in. What do we put on the top of word if we want to mean the opposite? Irrational. Irrational. All the numbers you cannot write as a fraction. So like pi, square root of 2, b. Like, what are you talking about? We'll get there. These are fascinating numbers. So now we have rational and irrational. Okay. We should get the big zoom in. So let's go over this again. Top corner. Natural, whole, integer, rational, irrational. Whew. That seems like a lot. Let's do a picture because this is what we do. Okay. Now, we start in the inner world. Now, all these sets get a fancy number. Natural numbers get a fancy number n, and we say that's the smallest set, okay? Whole numbers, fancy w. They're the next biggest set because they add 0. Then the next one out is integers, and this is Latin again, we'll have to talk about this. That's z. That's just what we call the integer group. And then on the outside of all that is rational numbers, which we call Q. Also Latin. We'll get there, okay? And then over here, though, because remember, these are rational, okay? And then over here, in this little corner all by itself, are the irrational numbers, okay? And then all these numbers, oh shoot, irrational is actually not an I, are what we call real numbers, and that's what gets the fancy R. So real numbers are anything that exists in the natural plane. And that encompasses the irrational numbers, the rational, the integers, the whole numbers, the natural numbers. You'll notice the natural numbers are everything except irrational. They're whole, integers, rational, and real. But so you have to say, okay, the same way that there was rational and irrational, if we're saying numbers are real, what's the last set of numbers? You guessed it, kids. Imaginary. That's really more for like trig and calc, though. Put that in your hair and rub it.